Assalamu alaikum. It's Mohammed Zainabas from class CS14D, and my groupmate is Absar Ahmed. And the project for our theory of automata and formal languages final and semester project is Marvel Quantum Recognizer, the course taught by Dr. Sohail Iqbal. So, the problem with the classical grammar recognizers is that it gives you a binary output that is either language is accepted or it is not. There is no confidence level or there is no probability involved. So you cannot say that you are this percent sure about anything about a particular string belonging to a language. The second problem with classical grammar recognizers is that they do not show probability, and do not you cannot visualize anything like you can show the derivation tree, you cannot show the derivation tree, etc. So the other problems are listed over here. So the solution for this is a quantum grammar recognizer that we have made for our end semester project. So let me show you our uh, project. Okay, so this is our project. Here, a few languages and example grammars are given. You can switch between them and choose anyone. For example, I am selecting A and B in language, and mainly we have focused on context-free grammars (CFGs). So, first of all, you can write the non-terminal variables over here, and then you write the terminals over there here, and you define the start symbol and the production rules for a particular language. So this is a very simple language, and we have also given example strings that you can test, and also the token sequence. So, for example, I select A B, and I run recognition on this language whether it is accepted in AN, BN or not. So here are the results. So the language or the string that I have given to the quantum recognizer says that it is accepted with a probability of 0.944. So you are shown amplitudes over here. There is another tab which you can click and watch every possible parallel computation of derivation paths, and only one is matched and two of them are not matched, and their probabilities are also shown over here. Similarly, you can also see the CYK table, which I will explain later, and also the inference logs, like how step-by-step calculation on how our quantum recognizers engine reached on this on conclusion. Similarly, you can pick another string. For example, I pick this one, which is not accepted. So here it shows that it is not accepted, and the probability of acceptance is also shown, and the individual probabilities of all the derivation paths are also shown over here. Similarly, you can select any other uh, language or grammar and test those as well. For example, palindromes and parentheses हो गए, arithmetic expressions, etc., etc. So this is our project, and now we come to the underlying working of our project. So here is what happens. When you give an input string and you define the grammar in our project, there are four steps that are taken. First of all, the grammar is converted into Chomsky normal form. We have studied Chomsky normal form in our slides and lectures, so I am not going to spend time on explaining it. The second step that occurs is CYK amplitude table. So what happens is that it is a n cross n table where each cell stores a quantum amplitude for every non-terminal that spans tokens I through j. All right, amplitudes multiply like a tensor, and values are calculated for it. After that, a derivation path simulation is calculated. A breadth first expansion of all the leftmost derivation runs in parallel. Each thread carries an amplitude that splits evenly across sibling rules, prefers shorter ruled bodies, decays gently with the depth, and threads whose terminal fix contradicts the target are terminated immediately. When too many threads exist, the weakest are pruned, alright? And the last step is measurement. The CYK result and the simulation result. CYK counts for 70% and simulation result counts for 30%. And both of them are blended into a final acceptance probability. And if the probability is greater than the threshold that we define in our quantum grammar recognizer, then it is accepted, otherwise, it is rejected. So, yes, that is essentially how our project works. Thank you so much.